In this video, we'll be learning about a mathematical expression called the difference quotient. For a given function f, the difference quotient is the expression f of x plus h minus f of x all divided by h. For now, the difference quotient is just a complicated expression that we want to simplify. In the future, we'll learn about its significance when we talk about rates of change. The difference quotient is an important part of calculating derivatives, which is one of the main things that you'll be doing in calculus. So let's take a look at some examples of finding and simplifying the difference quotient for various functions. In our first example here, we are given the function f of x equals 5x minus 1, meaning we have the function f, where when we input x into the function, the output that we get is 5x minus 1. When we evaluate the difference quotient, what we want to do is we want to break this expression up into three parts. We have the portion that's f of x plus h, we have a portion that's minus f of x, and then we have the h in the denominator. Let's start by writing down what each of those portions are for our specific function here. Let's start with the f of x plus h. Our function is 5x minus 1. So if I want to figure out what f of x plus h is, I replace this x with the input x plus h. So this is going to be 5 times, instead of x, we have x plus h, and then minus 1. When I replace the x in the formula for my function with the x plus h, I put parentheses around the x plus h because I'm replacing one thing with a sum of two things. So those two things need to be grouped together. Now that we're done with the f of x plus h, let's move on to the minus f of x. So start by writing down the minus sign, and then we write in what f of x is. F of x is given to us from the very beginning. We know that f of x, the output of my function when I input x, is 5x minus 1. So I'm going to replace f of x with 5x minus 1. Again, we need parentheses around the 5x minus 1 because we replaced f of x, which is one term, with something that has two terms. And those two terms need to be grouped together because eventually we have a minus sign to distribute. Now the last part of this difference quotient is the h in the denominator. So let's divide everything we have here by h. So this is the difference quotient for our function f. Now, to simplify the difference quotient, our main goal is to somehow cancel out this h that's in the denominator. What we'll do is we'll work with the numerator, simplify that, and see if anything cancels out. So, for example, we can start by distributing this 5 here, and we can also distribute this minus sign. So in the numerator, distributing the 5 gives us 5x plus 5h minus 1. And then distributing the minus sign, we get minus 5x and then plus 1. All of this is divided by h in the denominator. Looking at the numerator here, we see that certain things are going to cancel out. For example, we have a positive 5x and a negative 5x, so those two cancel out. We have a negative 1 and a plus 1, so those cancel out. We're left with 5h in the numerator and h in the denominator, and since there's a common factor of h both on top and the bottom, we can cancel those out, leaving us with just 5. And so this here is our simplified difference quotient. Let's take a look at an example with a different function. In this example, we're working with the function f of x equals x squared minus 3x. So if we want to evaluate and simplify the difference quotient, first we want to break this down into three parts: the f of x plus h portion, the minus f of x portion, and then the h in the denominator. Let's write down what each of these three parts are. Starting with f of x plus h. Remember that f of x plus h means we want to find the output of our function when we input x plus h. So go to the formula for our function, and everywhere you have x, we're going to replace them with our new input x plus h. doing so, we end up with x plus h squared minus 3 times x plus h. Again, it's important that when you replace one thing with something that has multiple terms, it's important to put parentheses around your expression. Now, our next portion of the difference quotient is the minus f of x. So first, write down the minus sign, then write in what f of x is. F of x is x squared minus 3x. And once again, we're putting parentheses around the x squared minus 3x because we're replacing f of x with something that has multiple terms. Lastly, we divide everything by h. When simplifying this difference quotient, our main goal here is to somehow cancel out this h that's in the denominator. But in order to do that, we need to first simplify things in the numerator. So what we'll do is we'll multiply out x plus h squared. We'll distribute this minus 3 here, and we'll also distribute this minus sign here. Remember that if you want to multiply out x plus h squared, you want to think about this as x plus h times itself. Once we write out the product in this way, we can use the FOIL method to multiply things out. Multiplying out the first terms, we get an x squared. The outer terms will give me an xh. The inner terms gives me an h times x. And then multiplying the last terms, we get an h squared. Now, the xh and the hx can be combined together. We get 2 copies of xh. So this is x squared plus 2xh plus h squared. So let's go back to our difference quotient and write out our numerator. So the first portion, the x plus h squared, gives us x squared plus 2xh plus h squared. Then distributing the negative 3, we get a minus 3x and minus 3h. And then lastly, distributing the minus sign, we get a minus x squared and a plus 3x. And all of this is divided by h in the denominator. Looking at the terms in the numerator, we see that certain things will cancel out. For example, we have a positive x squared here and a negative x squared here, so those two things can cancel out. We have a minus 3x and a plus 3x, so those two terms can cancel out. So what we have left here is 2xh plus h squared minus 3h in the numerator and just h in the denominator. One thing you might notice is that each term in the numerator has a factor of h in it. So we can factor that h out to get h times 2x plus h minus 3 in the numerator and h in the denominator. And since both the numerator and denominator have a common factor of h, we can cancel those out, and we're left with just 2x plus h minus 3. So for the function f of x equals x squared minus 3x, our simplified difference quotient is 2x plus h minus 3. Let's look at one last example with a different function. This time our function is f of x equals 1 over x. Once again, if we want to write out the difference quotient, we'll break this apart into 3 portions. The f of x plus h portion, the minus f of x portion, and then the h in the denominator. Let's start out by writing out the f of x plus h. Our function here is 1 over x, so f of x plus h would mean that we replace this x in the denominator with our input x plus h. So f of x plus h is 1 over x plus h. Next, we have minus f of x. So write down the minus sign. Then f of x is 1 over x. And then we want to divide everything by h. So this is our difference quotient, but what we want to do is we want to simplify this. We want to somehow work with this so that we can eventually cancel out that h in the denominator. To do so, we need to work with this numerator here. One thing we can do with the numerator is to combine those terms into a single fraction. In order to do that, we need a common denominator. And the common denominator that we're going to use is the product of the two denominators. So in our first fraction, we need to multiply both the top and the bottom by x. In our second fraction, we need to multiply the top and the bottom by x plus h. So let's do that and see what we end up with. So for our first fraction, multiplying the top and the bottom by x, we have x divided by x times x plus h minus, in our second fraction, we multiply both the top and the bottom by x plus h, so we have x plus h divided by x times x plus h. And all of this is still divided by h. Now that the two terms in the numerator have a common denominator, we can combine them together by subtracting their numerators. So this gives us x minus x plus h in the numerator, and we combine our fraction together, so we have that common denominator. And then all of this is still divided by h. To simplify this, we can distribute this minus sign to get x minus h divided by x times x plus h. All of this is divided by h. We see that the x's will cancel out, so our fraction simplifies to negative h divided by x times x plus h, all divided by h. Now what we have here is called a complex fraction, because we have a fraction where the numerator in itself is a fraction. To simplify complex fractions, instead of dividing, we can multiply by the reciprocal. So we can write this as negative h divided by x times x plus h, and then again, instead of dividing, we multiply by the reciprocal of the denominator, which is 1 over h. Now, it's clear that we can cancel out these common factors of h, and we're left with negative 1 divided by x times x plus h. So this here is our simplified difference quotient. So in this video, we've learned how to evaluate and simplify the difference quotient.